please take a moment and pause the video if needed to read over the problem given. Once you have done so, notice we're trying to find the speed of train A and the speed of train B. So I have drawn myself two different pictures here for the two different scenarios, and I've labeled them to help us identify what is going on. So the first example, we'll look over here on the left, where we have train A leaves at 9 o'clock and it's going to be traveling towards train B, and then train B is going to start over here at 10 o'clock and travel towards train A. They're going to meet at noon here somewhere in the middle. We do not know how far each individual one has traveled, but we do know that collectively from A to B is 216 kilometers. So we can identify the time traveled for train A and for train B. So if they leave at 9 for train A and it gets there at noon, well, we know that that's going to be a 3-hour total of travel. And train B leaves at 10 and meets at noon, so it's going to be 2 hours of travel. So we know that given information, and we know the distance. So don't forget your distance formula is rate times time equals distance. So if I look at train A, see how long it goes, 3 hours, and I multiply it times A, the speed, that's going to give me the distance of train A. So it's going to be 3 times A. And then if I add that to the distance that train B travels, which we know the total to be 216 kilometers, then I have an equation. So train B, the distance, will be found by taking the time times the rate. So 2 hours times the rate, or the speed, which is B, is unknown. So I have 2 times B. So that's going to be one of my equations, the first one. 3A plus 2B equals 216. Now scenario number 2, we'll look over here on the right. Same setup where train A is traveling towards train B is going towards train A. They meet in the middle somewhere at noon. So train A, if it leaves at 10:30, we know that it's going to be traveling a total of 1.5 hours. If train B leaves at 9 o'clock, we know it's going to be traveling a total of 3 hours. So same idea over here, where I can set up my first equation, my second equation, by taking the time traveled for train A, so 1.5 hours, times the rate that it's traveled, which is unknown. We call that letter A. And if we add that once again to the distance for train B, which is found by taking the time, 3 hours, times the rate, which is B, then we know that the total distance is going to be, once again, 216 kilometers. So we have our two equations given to us, right here and right here. So what I can do is I can now combine them, and I have a system of equations. But first, let me take this one over here on the right and multiply everything by 2 to get rid of that decimal. So when I do that, I'm going to get 1.5 times 2 is going to give me 3 times A. And then 3B times 2 is going to give me a 6B. And then a 216 times 2 is going to give me a 432. Okay, so now I have two equations, and the decimal is gone. So with a system of equations, I can either add them together or subtract them from each other. So I'm going to subtract them from each other, and when I do that, make sure I subtract everything. So 3A minus 3A is going to cancel. 2B minus 6B will give me a negative 4B. And then 216 minus 432 is going to give me a negative 216. So now I divide both sides by negative 4. I'm going to get B equals 216 divided by 4. It's going to give me 54. So B is 54. I need to find A. So to do that, I just plug that back into one of my given equations. So let's take a look at this one right here. And I have 3A plus 2 times 54 gives me 108. And that's going to equal 216. I'm sorry, I'm running out of room. I cannot write the 6 in there. So what I do is I can subtract 108 from both sides. I get 3A equals 216 minus 108, which will give me 108. Divide both sides by 3. I'm going to get A equals 36. So A, the speed of train A is 36 kilometers per hour. and then the speed of train B is going to be 54 kilometers per hour, and that is my final answer.